Good afternoon, ladies and gentlemen. Our objective for today is to be able to solve problems involving exponential growth and compound interest. Compound interest is a different type of exponential growth, so in reality we are simply focusing on exponential growth today while also looking at compound interest, which is just another way of having exponential growth. The first thing that we need to do in order to be able to figure out some of these exponential growth problems is to be able to convert each percent to a decimal. In order to do that, we need to do one of two things. You can either bump the decimal 2 places to the left, or you can divide the number by 100. So we can say 2 places left, or you can divide by 100. Dividing by 100 and moving 2 places to the left are the same thing. So let's look at a couple of what these answers would be just to make sure we are all on the same page. For the first problem, 35%, if I divide that by 100, I get 0.35. If I divide 20% by 100, I get 0.2. If I divide 8% by 100, I get 0.08. If I divide 9.1% by 100, I get 0.091. If I divide 5.67 by 100, I'm going to get 0.0567. And if I divide 0.1 by 100, I'm going to get 0.001. That is how you are going to be converting numbers to, or percent to decimals. Next up, we have to look at the exponential growth function. This is the standard form of it. So exponential growth is the initial amount that increases at a steady rate over time. The y value is representing your final amount. Your a value is representing your initial amount. Your r value is your rate or percent as a decimal. Your t value is the amount of time that you are spending doing the thing. A good way that I like to remember these three things is YART. And let's go ahead and take a look how this would work. You bought a sculpture in 2004 for $380. It increases in value by 8% each year. What is the value in 2012? So if I remember YART, I have my final amount, I have my initial amount, I have my rate, and I have the amount of time that I have spent doing it. So I do not know how much this thing is worth yet. That's what I'm going to be trying to figure out. My initial value is $380. It is increasing in value by 8% each year. Remember that percent needs to be a decimal, so if we take 8 and divide it by 100, we have 0.08. And the amount of time we are doing this for, I'm going to think to myself, from the year 2004 to the year 2012, how much time has passed? That would be 8 years. All I have to do now is plug it into my equation and I will be all set. So I say y equals 380, 1 plus, because I am doing growth and my rate is 0.08, and I'm doing that for 8 years. At this point, all I have to do is type this equation in on my calculator and I will get my answer. So I'm going to do that really quickly here. So I say 380, 1 plus 0.08 raised to the 6th power. And I get that this painting is worth $603.01. Students always ask me, how do I know what to round to on these problems? In this situation, we are dealing in money, so I would round to the nearest penny. Next up, a house originally cost $20,000 in 1950. The value increased 5% a year all the way to 2010. What is the value in 2010? So once again, I am going to say yard. And my final amount, I do not know what that is yet, so I'm going to leave that blank. My initial amount is $20,000. My rate is 5% that it is increasing at, so I write that as a decimal. And my time, this time I'm going from 1950 to 2010, so that is going to be 60 years. So what I'm going to do is then plug that into my equation here. So I'm going to go ahead and say y equals, my initial amount is 20,000. 1 plus 0.05, and we're doing that for 60 years. So I'm going to go ahead and type that in on my calculator and see how much this house is worth. When I type that in on my calculator, I see that this house is now worth $373,000, $583, and rounding my pennies, I have 72 cents. So this house has increased a lot since it was built in 1950. Moving along. Next up, we have to talk about compound interest. This is something that will be used in banks, or it's also used in mortgage payments. So compound interest arises when interest is added to the principal, so that from that moment on, the interest has been added also earns interest. So here is our representations here. We have A is our final amount. Smartboard, work with me here. Next up, we have the P, which stands for initial principal, stands for initial amount. The R is still our rate as a decimal. The N is the number of times that something is being compounded. And the T is, trying to grab that again. The T is the number of times in years. So when we compound things, we need to look at our number of times that something is going to be compounded. And you will see words in the problems that will give you a hint as to how many times something is compounded. If something happens annually, that means it happens once a year. If something happens semi-annually, that means it happens twice a year. If something happens quarterly, that means it happens 4 times a year. If something happens monthly, that means it happens 12 times a year. If something happens weekly, that means it happens 52 times a year. So the next thing, we're going to go ahead and do a practice problem here. It says you have $1,000 that you want to invest. You find a bank that offers a 5% interest rate and compounds quarterly for savings accounts. What is the balance in the account after 10 years? So what we are trying to figure out is how much our bank account is worth. So originally, our original principal is $1,000. Our rate is 0.05 as a decimal, because that is 5% written as a decimal. The number of times that this thing is compounded per year, well, I see the word quarterly, so that tells me that this is going to be compounded 4 times a year. And we want to do this for 10 years. The next thing that we need to do is write ourselves an equation. So if we look back, our equation is right there on the board. So we're going to go ahead and we say our total amount is going to be our initial amount times 1 plus, it is our rate over our number of times compounded. So it's our rate, which is 0.05, divided by our number of times compounded. And then we also have that, our n times our t, if we look there, it is n times t. We have n times t. And our N times our T is going to be 40. Now, after we do that, all we have to do is type that in on our calculator, and we will figure out how much our bank account is worth. So I'm going to go ahead and do that right now. And when you type this in, I would just like to remind you to be careful when you're typing this in, because if you mess up even one little thing, it's not going to give you the correct answer. So when you do this, you want to be very careful when you type it in. And our bank account is going to be worth $1,643.62. So not bad for just letting it sit in the bank. We have one more problem that we are going to do. It is a comparison problem. We have two different banks. They are going to offer you two different rates, and we're going to see which one is better. So the initial principal that we have for bank number 1 is $5,000. The rate for that bank is a 4% interest rate, so that's going to be 0.04. The number of times that thing is compounded is going to be monthly, so it's going to be 12 times. And we're going to let this sit in the bank for 5 years. The next bank, which is bank number 2, our initial principal is still $5,000. The rate for that bank is 0.08%. And that is going to be compounded semi-annually. That means twice a year. And we're still doing that for 5 years. So let's go ahead and figure both of these out, and then we will figure out which bank is the better choice. So we go ahead, write our equation. Our N times our T is going to be 60 in this case. And we'll go ahead over here, write our equation. And our N times our T is going to be 10 in that case. So now I can go ahead and type both of these in on the calculator and figure out what the answer would be. If you're going to try this yourself, this is a good time to pause. I will be going ahead and typing these in. So for our first answer, we get an answer of $6,104.98. Let's type in the second problem here. And for the second bank, you would get $7,401.22. So at this point, I think it is pretty obvious I would choose bank 2 to invest with in this situation. With that being said, that is the end of our notes for today. Have a great day.
Well,